Okay, Mr. Sonnenberg here. We're discussing Science 9, the unit matter and chemical change. Today we're going to talk about the general outcome number 1, but more specifically, specific outcome 1.1, and we're going to investigate and describe properties of materials. Again, what we're talking about in the general outcome 1 is how can we classify matter based on its composition and its properties. So today we're going to just specifically discuss the physical properties. Now there's both physical and chemical properties, but we're just going to stick to the physical properties and help you identify physical properties in terms of both qualitative and quantitative, and those terms will make a lot more sense as we make our way through the screencast here. So when we look at physical and chemical properties, or as we're going to move into physical and chemical changes, we need to understand what physical properties are and what chemical properties are. So matter can be identified by both its physical and chemical properties. And remember, matter is anything that has mass and takes up space. So I have an example on the screen that discusses oxygen and iron in the formation of rust. And you'll notice there's a few bolded terms and some terms in brackets that physical and chemical to help you identify through this example of exactly what physical properties are and chemical properties are when you're trying to identify either. So the example states that, or says, oxygen is a colorless gas that combines with iron to form rust. Now, we're all, I guess, we've seen rust before, and I know if any of you have seen my old Ford truck roll up to the school, you'll see that I have a little bit of rust on my vehicle, on the bumper, on the fender. It's a nice truck. It serves the purpose of getting from point A to point B, but it is turning into quite the rust bucket. So the process where iron or oxygen and iron interact is what forms that rust, and that's how I've developed rust on my truck, and I know we've probably seen it in many other places. If anyone plays baseball, sometimes the backstops, they have rust, and the fence posts and such, and the chain link fence, there's rust on them. So we've seen rust, and again, if you want to look at my truck, you'll see some rust. But the example is oxygen is a colorless gas that combines with iron to form rust. Now I've bolded the terms colorless gas and combines with, just to help clarify what the difference between a physical property and a chemical property is. So colorless gas is bolded because it's identifying that oxygen is in fact colorless and it is a gas. Its state is gas and we can't see a visible color. And now the words combines with are referring to the iron, and now it's talking about a chemical property, and we'll discuss that in the next section, what chemical properties are, but it's combining with oxygen, the iron is, to form the rust. So how does it interact with oxygen? And so these chemical properties are going to discuss how substances react with water, with other pure substances, with oxygen and such, and form new substances. So, but today what we're going to discuss is just the physical properties. So a physical property, what is it? Well, they can be observed without forming a new substance. Okay, so we can look at it, and we know that with this physical change, basically what in physical change, what we're going to be looking at is just a change in composition, or not a change in composition, sorry, just a change in state. But what are physical properties? Well, we're going to group physical properties into two categories, and we're going to group them into qualitative physical properties and quantitative physical properties, and we'll discuss the difference between the two as the screencast moves forward. Qualitative physical properties. So these are properties that we can identify through our senses. So some of these properties include color, texture, taste, smell, change in state, malleability, so that's its ability to be shaped, ductility, its ability to be stretched. So I can view things, and what we're going to do is I'm actually going to, later in this segment, we're going to look at aluminum, and we're going to discuss some of these physical properties, but these are qualitative properties on the screen right now. Okay, so these are we can look at these. I can knock on my countertop and I can say, yep, it's hard, but it's smooth. I don't think I'd want to taste my countertop, but I can smell it, and I can view maybe an ice cube and water, and I can watch it change state if I put an ice cube on my counter and watch it melt and change from a solid to a liquid. So now discuss the other category of physical properties are quantitative physical properties. Now these are different than qualitative physical properties because they require a measurement of sort. So we can measure these properties, and so some examples of this includes what is the substance's melting point, its boiling point, density, which is our mass divided by our volume, viscosity, looking at its flow rate, how fast or slow does it flow, solubility, its rate of dissolving, and then again terms that go along with solubility, we would want to look at the solute or the solvent and talk about soluble, and then conductivity, so that's its ability to for electricity to flow. So let's take a look at aluminum now and just identify its physical properties, both qualitative and quantitative. And I hope we understand the difference between qualitative and quantitative. Qualitative being we can view it with our senses, and quantitative that we can measure it. And I've always looked at quantitative, and I've seen the word between quantitative and qualitative, and I've seen the word and I've seen the N in quantitative, and I've thought of numbers. And when I think of measurement, I think of numbers, and that's how I associate and distinguish between the two in my own brain, and maybe that works for some of you. But let's take a look at aluminum. So aluminum's physical properties. Well, aluminum is silver in color. It's solid at room temperature. It's a soft metal. Its melting point is 660 degrees Celsius, and its boiling point is 2,519 degrees Celsius, with a density of 2.7 grams per centimeter cubed. Now, if we look at this, we can identify that silver in color is referring to a qualitative physical property. Solid at room temperature is also referring to a qualitative physical property. It's a soft metal, so we can use our finger, we can touch, and we're using our senses, and we can determine that that is a qualitative physical property as well. Now let's go into the quantitative physical properties of aluminum, and that's its melting point. Okay, remember, quantitative, the N in the word quantitative can refer to numbers, and numbers we can try to remember measurements. So now what we're doing is we are classifying it as quantitative, and it can be measured in degrees Celsius. So that melting point at 660 degrees Celsius is quantitative. And its boiling point at 2,519 degrees Celsius is also a quantitative measurement or property. And then its density being at 2.7 grams per centimeter cubed is also again a quantitative measurement. So hopefully now we have a clear understanding of how to identify between both or quantitative and qualitative physical properties, and in the next segment we'll discuss chemical properties of substances, and then we can distinguish and decipher between the two of those. So hopefully this has helped you better understand physical properties, and you've expanded your knowledge in this subject area.